In order to write the electron configuration diagrams, the orbital diagrams or box and arrow diagrams, we first need to learn about sublevels. So principal energy levels are given numbers, 1, 2, 3, 4, etc., with 1 being closest to the nucleus of the atom, and the numbers get larger as they get farther out. Now, there are different types of sublevels that each principal energy level can hold. The S sublevel has 1 orbital in it. The P sublevel has 3 orbitals. The D has 5 orbitals, and the F has 7 orbitals. So notice these are consecutive odd numbers, 1, 3, 5, 7. The S, the P, the D, and the F actually stand for something dealing with how the electrons appear on some type of test that's done to figure out where the electrons are. We don't need to worry about that, but that's why the weird letters. Beyond F, they just start going alphabetically. So if you have something with a 5th sublevel, it would be G, then H, then I, etc. And those would be, so 1, 3, 5, 7, the next would be 9, 11 orbitals in it. Each orbital can hold 2 electrons. So the S sublevel, which has 1 orbital in it, that whole sublevel can only hold 2 electrons. Now, when electrons are in the same orbital, they're always going to be facing in opposite directions. And we represent electrons as arrows. Sometimes it's kind of a half arrow, only using one side of that arrowhead just to save time. Doesn't seem like too much, but when you're drawing thousands of arrows a day, every little bit helps. So the S sublevel has 1 orbital, and that orbital can hold 2 electrons, 1 up and 1 down. The P sublevel has 3 orbitals. Each orbital can hold 2 electrons. So every orbital, regardless of what level it's in, can hold 2 electrons. Because there's 3 orbitals, each one can hold 2. That means the P sublevel can hold 2, 4, 6 electrons. When we're filling the orbitals, we always put 1 electron into each orbital before doubling up. So if the P sublevel had 3 electrons, it would look like that, 1 in each. Once we get a 4th electron into the P sublevel, then we need to double up, and that second arrow would be facing down. The D sublevel has 5 orbitals. Again, each orbital can hold 2 electrons, and we put 1 electron into each orbital before doubling up. So each orbital can hold 2 electrons. There's 5 of them, so the D sublevel can hold 10 electrons. And likewise, the F sublevel has 7 orbitals. Each orbital can hold 2, so it can hold a total of 14, but when we're putting the electrons into orbitals, again, we always do 1 in each orbital before doubling up, and we can see that it can hold a total of 14 electrons. So when we're placing electrons into orbitals, first we need to realize that not every principal energy level has every sublevel. The first principal energy level only has 1 sublevel, and that sublevel is an S. The second principal energy level has an S sublevel and a P sublevel. The 3 principal energy level has an S, a P, and a D sublevel. The 4 has an S, a P, a D, and an F sublevel. The 5th has S, P, D, F, and now we add another one, a G. So if you look at the number for the principal energy level, that actually tells you how many different types of sublevels there are. The first principal energy level has 1 sublevel. The second principal energy level has 2. The third has 3. The fourth has 4. The 5th has 5, which I did manage to fit up to a G on this particular diagram here. The 6th would have S, P, D, F, G, and an H. 7th would have S, P, D, F, G, H, and I. There just wasn't enough room on this paper, and honestly, we're never going to be using those higher sublevels anyhow. Now, when we're putting the electrons into their location, again, we need to pay attention to what sublevels actually exist. Electrons always want to have the lowest amount of energy possible. We put 1 into each orbital within a sublevel before doubling up, and never more than 2 in an orbital. And the first one goes in up, the second one, if I do have to double up, would go down. So you might be thinking, okay, so I'm sorry. Esther, get down, please. I do 1s, then 2s, then 2p, then 3s, 3p, 3d, 4s, 4p, 4d, 4f, but that's not actually how it works. These all have different amounts of energy in them. Every orbital within a given sublevel has the same amount of energy, but the different sublevels have different amounts of energy, and there is some overlap. In terms of why it works that way, that's just the way God made it. It's determined based on solving a mathematical equation. And this is kind of a general diagram of the amounts of energy with lowest at the bottom, highest at the top. The spacing in between these is completely different. But essentially, the 1s sublevel does have the least amount of energy, which is the one I'd figure I was going to fill first. Then the 2s, then the 2p, then the 3s, then the 3p. But if you'll notice, the 4s actually has less energy than the 3d. So I want to put electrons into the 4s before I go to 3d. And then after 3d, I go to 4p, and then 5s, and then 4d. It looks like it's getting really mixed up. But the wonderful thing is you don't have to memorize that. If you can create this diagram can help you figure out how to fill the energy levels. If you write it out this way, then what you're going to do is you are going to fill along the diagonal. If we do a diagonal, it goes first through the 1s, then through the 2s, 2p, 3s, then 3p, 4s, then 3d, 4p, 5s, etc. So that's the order that we just determined they're supposed to be filled. And that will always work as you keep going. There would be 4d, 5p, 6s, then 4f, 5d, 6p, 7s, then 5f, 6d, 7p, 8s. We can continue expanding this as we need to, but we're really never going to have to go farther than that. So doing the electron configuration for any given element, if you look up the atomic number of the element, that tells you how many electrons it's going to have. Let's just do element number 118, because that's the highest one there is on the periodic table, which means it's going to have the most work with it. And if you're understanding how to do this, you can stop the video partway through. You don't have to get all the way to the end. All right, so we're going to have 118 arrows in my diagram. And if I look over here, remember, this is going to tell me the order that I'm going to fill the sublevels. I need to fill 1s first. Now, I'm going to write down 1s. That's the principal energy level and the sublevel. You'll remember that every s sublevel has one orbital. And that one orbital can hold 2 electrons. So 1, 2. I'm going to keep track up here of how many I have done so far so that I don't have to keep going back and counting every time. Once I have those 2 electrons in the 1s, that 1s is filled. I've put 2 electrons into my atom, but I need 118. That means I'm going to need more electrons. So if I come back to this diagram, I've filled in the 1s. Now I need to put in the 2s sublevel. So 2s, again, every s has 1 orbital in it. And that 1 orbital can hold 2 electrons. All right, so now I've put in a total of 4 electrons. Again, I need 118, so I'm going to need a few more. After the 2s, I'm going to go to the 2p. The 2p has 3 orbitals in that sublevel. As I put those electrons in, remember I'm going to put 1 electron into each orbital before doubling up. And because each orbital can hold 2 and there were 3 orbitals, that's a total of 6 electrons. I had 4, I just put in 6 more, so I'm up to 10 now. Still need more. After the 2p, I'm going to go to the 3s. Every s only has 1 orbital, so it can hold those 2 electrons. I'm up to 12 electrons now. After the 3s, I go to the 3p. So 3p, every p orbital is going to have 3, or every p sublevel has 3 orbitals in it. I just put in another 6 electrons, so I'm up to 18 electrons by the time I have the 3p filled. After 3p, I'm going to hit the 4s. Every s sublevel has 1 orbital that can hold 2. That gets me up to 20 electrons. After 4s, I'm going to circle back around to this next arrow. I'm going to go to 3d. 3d, every d has 5 orbitals in it. So 1 in each orbital before doubling up. 5 orbitals, each holding 2, gives me another 10 electrons, so I'm up to 30. After 3d, I'm going to go to 4p. Every p has 3 orbitals in it. Which is another 6 electrons. After the 4p, I go to 5s. Every s has 1, so that gets me 2 more, which gives me 38. After the 5s, I go to 4d. Again, every d has 5. One in each before doubling up. It's a total of 10, so I'm now up to 48 electrons. After the 4d, I go to 5p. Every p has 3. So adding 6 more electrons gets me up to 54. After 5p, I have 6s, which has 1 orbital, 2 electrons. I'm up to 56. After the 6s, now I'm going to swing around and hit 4f. So this is my first f orbital. Remember, it has, or first f sublevel, which has 7 orbitals in it. So that gets me up to 70 electrons. After 4f, I'm going to hit 5d. All Ds, remember, have 5 orbitals in them. Which gets me up to 80 electrons. 5d, now I'm going to swing 5d, 6p. Which added another 6, so I'm up to 86 electrons. 6p, now I'm going to go to 7s. would be 88 electrons. After 7s, now I'm going to 5f. Every F has 7. So 88, I just added 14. So I'm up to 102 electrons by the time I have 5F. Now I'm going to go to 6, hold on, that was 5F, 6D. Every D has 5, so 1, 2, 3, 4, 5. So I'm up to 112, and I ran out of room, so I need another sheet of paper. But I'm just going to continue. After 6D, I go to 7P. And 7P, every P has 3 orbitals in it, which is another 6, which gets me up to 118. So all of this together makes my box and arrow or orbital diagram for element 118. Obviously, if 118 has the most electrons of any element, this is the longest any of them can be. And you're very rarely going to have something this long. But that's essentially the most you could have to do. If there's fewer electrons than that, just stop wherever you get to the correct number of electrons. Now, as you can tell, this is a little long to be writing out for all the elements. So there are some shorthand notation ways of doing that. For example, for element 118, sometimes we just give the principal energy level, the sublevel, and then as a superscript, state how many electrons are in that sublevel. So this would be 1s, 2, 2s has 2, 2p has 6, the 3s has 2, the 3p has 6, the 4s has 2, the 3d has 10, the 4p has 6, the 5s has 2, 4d has 10, 5p 6, 6s 2, 4f 14, 5d 10, 6p 6, 7s 2, 5f 14, 6d 10, 7p 6. Notice you are missing some information in this. It's not explicitly stating how many orbitals are in each sublevel. It's also not telling you how many electrons are in each of those orbitals. So for example, if we had something with 4, with a, I'm going to use N for the principal energy level. If we had something that had NP4, it's not telling you that it's 1 in each of 3 sublevels and 1 that's doubled up. You would need to expand that, knowing what you know about the energies and how the electrons are put in to get that there's 1 set of paired electrons and 2 that are unpaired, and not that it's 2 orbitals filled with electrons and 1 empty. So this is a nice way of summarizing everything, but there is some information that isn't explicitly stated in that. The only other thing that we can do to make, well, there's a couple other things we can do to make it similar or simpler. Sometimes they'll take out everything up to the nearest noble gas, which is group 18, and just put that element in brackets and say, okay, this is the element or electron configuration for neon, and then going from there, here's the extra stuff on it. On your reference table, you will see an even shorter version of electron configurations, your reference table only tells you by principal energy level. It doesn't differentiate between sublevels. So yours would say, all of my ones are in the S, so it would say 2 dash, and then here's my second principal energy level, which has 2 plus 6, which is 8. My third, got to be careful with this one, 2 plus 6 is 8, but here's another 3, 10, so 18 dash. The 4 has 2 here, plus 6 here, which is 8, plus 10 is 18, plus 14, which gives us 32, and it groups together all of the things just within the principal energy level. This gives us really the least amount of information. There are some things that it's useful for, but in many cases we do need something with more detail about how those electrons are distributed throughout the atom. So remember, the order in which you fill things, how many energy levels each thing has. Always start with the lowest energy, which happens to be going through these diagonal lines, and 1 into each box within a particular sublevel before doubling up. 1 up and 1 down.